Hello, everybody. My name is Fabio Ugolini. I am a business consultant at INNOVA. I am the exploitation manager of HySolChem, and today I'm going to introduce you to how to conduct a state-of-the-art analysis and specifically how to use a pattern landscape uh, as an element of the state-of-the-art. With this lecture today, you're going to learn how you can obtain a patent dataset from one patent database, how to clean these datasets, and how to do some initial visualization that are normally included in a patent landscaping. The learning objective for this lecture is to teach you how to navigate in general patent databases and understand what kind of information you can get from them and how you can work with this information. You're going to extract four key information from the dataset that are going to allow you to do for visualization. The first one is the patent trend chart, which shows how many patents have been filed over a certain period. Then a most cited patent ranking that shows what are the patents which are more relevant in the field. A top inventors ranking showing the people who are working, who have been working behind the development of inventions in the field. And finally, the top applicants, which gives you a picture of who are the legal entity which have legal rights on the patents that you have been analyzing. We retrieve our information from patent databases, and there are several of those. You get a SpaceNet, which is the European patent database, Patent Scope, which is the WIPO patent database that spans all over the world, USTPO, which is the American patent database. There's a lot of those. Each country has a patent database which might be more or less complete. But you also have data aggregators that are looking at multiple databases at the same time, such as Google Patents or the Lens. In this lecture, I'm going to show you how to use the Lens in order to retrieve your patent information. We are going to look into the Lens database. The way it works is pretty straightforward. We select the patent database and then we just query our keywords. In our case, it's artificial photosynthesis. Here we have the possibility to use a more structured search. We can actually use Boolean logic in order to formulate a more precise query, but for the purposes of this exercise, we are just going for a simple keywords search. Once we click on search, then the database retrieves all the patent entries that relate to our query. We can already retrieve from this page a few information that are interesting. For example, you can see here that artificial photosynthesis is corresponding to more than 35,000 patent records and 18,000 simple families. The patent records are the total number of patent documents existing around the inventions, while the simple families is actually the number of inventions that are existing in this domain. For example, if I invent one reactor for artificial photosynthesis and then I patent it in 20 different countries, that's going to be one invention with 20 patent records. So these numbers, they are not excessively high, but it might be complicated to do a visualization within the scope of this MOOC. So one thing that we want to do, but in general we want to do it also in any patent landscaping activity, we want to narrow down the results to what is really relevant for what we're doing. One of the things that we can specify in which fields of the patent document the keywords are searched. And this is done through the refinement of the query by clicking on edit search. You can see that this query was searched in all the fields of the patent document. The patent document has got a title, an abstract, and then the claims that are explaining the nature of the invention. One quick way to refine the search is to just restrict the search to the title of the patent. This is going to give you patents which are strictly relevant with artificial photosynthesis. Once we refine the search, then we can see that the number of patents is going from 35,000 to 147, and the numbers of families is going to 90, which is a more manageable number. There are other filters that we can apply if we want to further restrict the search. For example, we could insert a date range or a specific jurisdiction where we are interested in the patent, but this level of refinement is sufficient enough for us to start analyzing the dataset. One thing we want to do before downloading the dataset is sorting the patent by citation, on the assumption that the most cited patents are going to be the most important patents in the field, which are the ones that we should put on our radar. So we select here cited by patent count. And another thing that we might want to do is to group all the patents by simple families, which is going to give us only the distinct inventions that exist in the domain of the artificial photosynthesis in this case. Once the patents have been sorted, we just click here on the export. We can decide the number of documents that we want to export. In our case, we have 90 entries, so we can select 100 documents. And then the format with which we want to have it exported. So now the most complete format is JSON, which needs to be parsed and cleaned, normally using some coding. We're not going into that for this lecture. We're downloading it in CSV, which is a format that can be cleaned using more common applications such as Excel. Here you can select the fields, the kind of information that you want to retrieve in your downloaded dataset. It's important to have the abstract, which is going to give you a description of what is contained in the patent. CSV datasets, they don't have the possibility to export the claims, which are the more extensive description of the patent, but we are not going to need it for now. So we select everything that we can select, and then we export. And this is going to be downloaded. Now that we have downloaded our dataset, we can open it with Excel, and this is how it looks like. It's just a very long table that contains all the fields that you selected to download when you exported the dataset from the lens. So we're not going to use all of these fields. So the first thing to do, we just delete the fields that we are not interested in. And I already did it. I would suggest that you make a copy of this worksheet so that you can keep the original dataset safe and stored. And in the copy of the worksheet, which I here name dataset, you can keep only the relevant field for your patent analysis. And those are the ID of the patent, the publication year, the title of the patent, the applicants, the inventors, and the cited by patent count, which is the way we sorted the patents when we exported it. just a distinction between applicants and inventors. Sometimes those are the same entity or the same person, but most of the time is gonna be different. The applicants, those are uh, the legal person that have ownership rights on the patent. If you want to buy a license to a patent, you have to deal with the applicant. The inventors, those are the people who have invented the object of the patent. They don't have legal claims of the patent. They have what are called moral claims. Uh, so normally, if you're just interested in licensing a patent, you will not have to deal with the inventors at all. You would only have to deal with the applicants. But for a patent landscaping analysis, it's interesting to know who are the people who worked behind an invention, because they could help you. It could help building your network, for example. Before we start with the data analysis, we have to do some data cleaning in the fields of the applicants and the inventors. So you may have noticed that some applicants, some patents, they have multiple applicants, and those multiple applicants, they are all uh, jumbled together in the same cell in the table that we're going to analyze. So we want to separate the applicants in different cells, and this is how you would do it in a very in the most straightforward way. You just copy the column at the end of the worksheet. So we have a duplicate applicant column. Then we select the entire column. We go to text to column in the data tab in Excel. We indicate that the entries in the cells are limited, and this is delimited by a semicolon. And sometimes we have consecutive semicolon. We just click on treat consecutive delimiters as one. Then we finish the process, and then we got all the applicants divided in different columns. So now we normally would have to consider all the columns with all the applicants. However, again, as part of this exercise, we consider just the first applicant, so we can delete the rest of the column. We repeat the same for the inventors. We take the entire content of the column, we paste it at the end, we select it, we click on text to columns, we select the limited separators, semicolon, treated consecutive, and then we finish. And also in this case, we have all the inventors separated, and we can keep only the first one. Now that the data set is cleaned, we can start with the analysis. We do that using a pivot table. You select the upper left corner of the table, you go to insert pivot table, and then when prompted, you create the pivot table in a new worksheet, and here you have it. With the pivot table, we can do all sort of visualization from the data that are retrieved from our dataset. The first thing we can do is to have a look at the patent trends throughout the year. So in order to do that, we get the lens ID and we drag it into the value field of the pivot table. If we leave it like this, it tells us the total count of the patent that we retrieved, which is 90 documents. And then we put the publication years in the row. And then you have a nice table which reports the number of patents for each year. Of course, we want to produce a visualization. So if you click on pivot table analyze and then you click on pivot chart, you could add, for example, a 9 chart that shows you the graphical trend of the patent each year. In our case, we have a dip in 2022, which some of you might remember for the pandemic. Everything was blocked, which is nicely represented in the patent trends for that year. We can then have a look at the most cited patents. In this case, we have to select the title of the patent. We drag it in the categories axis, and then the cited by patent count, and we drag it to the values. And then let's resize this table. You have the title of the patents with the number of times that the patent has been cited by another document. By right-clicking on the first one of the entries, you can sort it from, for example, smallest to largest, or maybe let's do largest to smallest. So you have the most cited patent, which in our case is carbon and fuel production from atmospheric CO2 and H2O by artificial photosynthesis and corresponding methods. So now the visualization, this is a leftover from the previous one. It's not really working for this kind of information. For this kind of information, having directly the table, this is what I would recommend including in any patent landscaping document. Using the same principle, we could get the list of the top applicants and the top inventors. We just need to drag the corresponding variables in the fields. So the first one is we want to drag the count of the lens ID into the values. Oh, it was already there, so now it's duplicated just one time into the values. And then we want to drag the name of the applicants into the rows. So now applicants 2 in the data set is the actual column that has that we cleaned earlier, applicants 2. So this is what we drag here, and we can sort largest to smallest, and we can see that the entity that was filing the most patents is Fujifilm Corporation, with 14 patents out of 100 patents dataset. So 14% of the production of patents is Fujifilm. Similarly, we can look at the top inventors, which case we can see the names of the people who have been actively working on research and development surrounding the field of artificial photosynthesis. And now we want to keep in mind that you can do all sort of visualization with the pivot table, and you're not necessarily restricted to these variables. The original data set had much more, so there's really a lot of ways to explore those data that you retrieve from a patent data set. Now, we're not going to go deeper into that. I hope that what we have seen so far is giving you at least an initial introduction on how to approach a possible patent landscaping and patent analysis activity. This concludes lecture number 7 of the HySolChem MOOC. I would like to thank you for staying with me, and please go and check our website and our socials.